Hello, everyone, and welcome. This is Professor Thayer with you here, continuing on with our discussion of the loops. This is third lecture on this, and so let us continue on. So we've been talking about the various syntaxes for the loops, and we've seen a couple of different styles of looping. And today we're going to pick up with the infinite loops. So an infinite loop is something you probably do not want to create. This usually happens because you have created it by accident. And so usually when this happens, this is something that we want to avoid. Infinite loops can occur when a loop fails to stop executing. It's generally bad because your program will be stuck forever. It usually occurs because there is an error in the programming. We need to take care of the edge cases. We've mentioned those edge cases before, and we also need to be sure that we are considering all possibilities when we are doing our coding. But it happens to the best of us. It still happens to me from time to time. You need to do the Control-C. This will break or stop the infinite loop from executing. You can also just X out of your Python, just like X out of your idle and restart it, and it will be fine. You need to, of course, change your code so that you remove your infinite loop. But don't worry, you won't break your computer with an infinite loop. But it's something that is bound to happen sooner or later. So let's just take a look at some of the cases where this sort of thing might happen. So the first case where this might happen is with your while true loop. So as we were talking about that style of a loop, it could be kind of a little dangerous to design your code this way because you need to be absolutely sure that you have made some way for the loop to stop being true, right? Because there's no real branch guard. The branch guard is always true, which means there's no way to stop unless, of course, you have put a break in here. And so as we can see here, this is probably someone developing some code. They are probably in the middle of developing it and want to test their code at this point. And so if you were to do that, let's see what will happen. So here, there's the password. It's flower55, and we have this while true loop, and the password as PWD will be the result of asking the user to type the password, and then it will print out you type the password, right? But then it'll go back to the top of the while true loop, and it's going to keep asking the user to enter the password. And even if they have typed it correctly, there's no way for this to stop. And that's why this will become an infinite loop. So there's a couple of ways that we could deal with this, but I'm going to illustrate one here, and let's take a look at this code to see what's going on. So again, we have our password being set here to flower55, and we have while true still, and we're getting the password as input, the same, and it's going to print out what they typed. Fine. Not super secure, but okay. And then we have this if statement being added. If PWD, the thing that they typed, is equal, remember this one will ask the question, are these equal? This is going to return a Boolean. If the password is equal to the actual password up here, that is, they typed the same thing as the password that's given, then they will print, congrats, you got the password. And here's the key thing, it has a break. This is a way for the loop to terminate. If the password, the PWD password and the password are not equal, it will say that's not the password, try again, and we go back to the while true. So fair enough, this is actually pretty good because you see what it will do is it will continue to prompt the user until they actually type the password. So let's just follow this through for some particular example. So here they run the code. It says please type the password, and they type SFD, and it reports back that that's what they typed. It's not the password, and it says that is not the password. So why is that? Because PWD is not equal to the password, so it's going to not go here, but it gets caught in the else, so it prints that is not the password. Try again. And so then we go back to the top of the while true loop. right? Because while true will just continue until something stops it. So now it says pwd equals input, please type the password, and then they their memory comes back and they type flower 55, and then it reports out what they typed right here. And now, does password and pwd line up? Well, it does. So this expression right here will be equal. This evaluates to true. So the if statement now executes, prints, congrats, you got the password. And then the key thing here is that we proceed to this break, which is a way for the loop to terminate. So the while true loop terminates, it goes to the next thing outside of the while true loop, which is nothing. There's an implicit return here, and that terminates the execute of function. So that's how that one would work. Here is a while loop with a loop variable incrementation missing. All right, so let's take a look at what's going on here. Here's a bug while index problem. And it's supposed to count to 10 by 2. It's not taking any input, implicit return. All right. I equals input, enter an integer from 0 to 9. And then we see while I is less than or equal to 10, it should print I. So the problem with this is hold on, let me. Sorry, there's actually two problems with that code. I'll leave it for you to see if you can spot that other problem. So continuing on now, I have updated this slide for you. The problem with this code is notice that the I is gotten from the input. So let's assume they do enter an integer from 0 to 9. So maybe they enter 5. I being 5 is in fact less than or equal to 10. And it will print out 5, and then it goes back to the top of the while loop, and I is equal to 5, which is less than or equal to 10. We print 5, and so you'll see that nothing ever happens to I to make this branch guard become false. And so that's a problem. So here's what we could do. We could, okay, first of all, make sure you convert your integer actually to an int. That was the mistake. And the other thing we need to do is we need to be sure to increment I so that it will get larger. So if they input 5 now, it will print 5, and then I will increment up to 7. And is I less than or equal to 10? Yes, print 7. Now it goes to 9. It's still less, print 9, increments, and now it's 11. And so you see that the branch guard is now false. So that fixes the problem. So the while loop where the branch guard is never false is also a problem. So here's another pretty simple while loop. I is going to be equal to 11 that's set in the code, and we say while I is greater than 10, which it is, it will print the index of I, and then we increment I to one more, which is now 12. Is 12 greater than 10? Yes, and so is 13, 14, and so on all the way up to infinity. So this one will never stop. So probably there was an error in the logic here. So here's something that we could do. We could say I equals 11 while I is greater than 10, print the index, and then we can decrement instead. So now 11 will come down to 10, and I is being 10 is not greater than 10, so that becomes false. So there's a way for this loop to stop. What you need to do to fix a problem like this really depends upon what you want this to represent. So it may be possible that the initial condition, what you set I to, is not right, or because maybe you do want to increment instead of decrement. But anyways, you need to set it so that there is some way for your branch guard to become false. All right, so the next thing we're going to talk about is nesting of loops. We saw the nesting with the if blocks. That is when an if statement actually initiates inside the branch of another if statement. And the same thing can happen with while loops. So there's, of course, many combinations because we have a lot of different while styles, and any one of them can exhibit the nesting. So I'm just going to give you a couple of examples here, and we'll start off with the generalized syntax so that you can get the idea of how that would work. So you'll have your initialization in some while loop, right? But inside of this, there could be the initialization and another while loop, which is inside the branch of the outer while loop. And so why not? That works perfectly fine. So the case when you would want to do this is if you want to have two variables. This is often when you would want to do that. Some outer variable I and some inner variable j. This can be really useful if you need to cycle over some ij coordinate space, that is getting coordinates, all possible coordinates for a grid. So let's just take a look at what this would look like in the practical sense. So here we have an I equals 0, and it says while I is less than 3. Oh, we have another loop inside of here, j equals 0 while j is less than 3. Print I and j, and then we'll increment j to go back up to the while loop. So this is going to increment until j reaches 3, and then the I will increment by 1, and we go back to the outer while loop. So let's just see how this would work. So in the beginning, I will be 0 and I is less than 3. So j will be set to 0. And while j is less than 3, we will print I equals and j equals, which is what we're printing out over here. We're basically printing out the variable table. And then we're going to increment j by 1. But where do we go from here? We go back up to the top of this while loop. So has I changed? No, it hasn't, because the flow has not gone down to I. So it goes back to while j is less than 3. So now j is 1. J is 1 and I remains at 0. So when we print I and j, we get 0 and 1. J increments another and up to the top. So we'll print 0 now and 2. And so when we get to when j is 2, we get j plus equals 1, so j is 3, and j is no longer less than 3. So this loop, inner loop, terminates, and we go to the first thing outside the loop, which increments I. But don't forget, this loop is still running. So I increments up to 1, and we go back to the top of this while loop, and it all starts again. So now j is set to 0 again, and is j less than 3? Yes, it's 0. So I is now 1, and j is 0. And so in a similar way, j cycles through its values until it gets up to 3, which terminates this loop before the printing. And then we go to I plus equals 1 to increment the I up to 2. And so we go to the back of the loop, and the whole thing goes all over again. I being less than 3, and j gets reset to 0, and we cycle through all of the 2's. Then after j reaches 3 and I plus equals 1 gets up to 3, then I is now no longer less than or equal to 3, which terminates the outer loop. And so that is how we escape. So that's how nested loops work. Like I said, it's really useful if you need to cycle over ij values, but you can use it for other things as well anytime you need to do a double cycle. You can also do nested while loops with a break. Now, let's just see what that would look like. So here's an example, and you could have the break in the outer loop or the inner loop. But when you have the break in the inner loop, what it's going to do is it's going to break to the outer loop. So this is in fact going to do exactly the same thing that our previous code did. So let's take a look. We have I equals 0, and while I is less than 3, right? J equals 0. We're starting the inner loop while true. So that's the initialization of the inner loop. Here's the actual looping, right? Print I and j. So again, we'll have 0 and 0. If j is greater than 3, is it? No, it's not greater than 3. So we will go to the next line, which is j plus equals 1. So j increments to 1 while true, print them out. And we see j is 1. So now it gets incremented to 2. We print ij with 0, 2. And then we go back to the top. We print ij, right? Notice that we get the I equals 0, j equals 3, just because of where the printing is. If I had put this if statement before the print, it would have stopped before we actually did the printing, but it's after. So if j is greater than or equal to 3, which it is now, it will break. And that causes us to jump out to the outer loop. So the I will increment by 1 and we go back to the top. So now I is equal to 1. And so j gets reset to 0 and we cycle through the 1s. And then we'll also cycle through the 2s in order to do this. But notice that instead of this stopping the execution when using the Boolean expression like we did before, is going to stop because of this break when it meets that conditional. So it's an alternate way you could write things. But the interesting thing is that the inner loop terminates, but the outer loop keeps going. And as we saw with break and a while, like a while true with break, then the outer loop will stop. But if you have a break inside of a while true that's nested, it will just escape out to the outer loop. So break is a kind of a soft way of escaping. It escapes one level above where you were. This leads us to also just consider return inside of the loops when you're inside of a function. So of course, return doesn't apply if you are not in a function, and usually you should be in a function. But what if you have a return and it's inside of a loop? Well, that will kill your function, right? So your function will terminate its execution whenever you encounter a return. So here's an example that somebody may have tried to attempt to do something similar to what we just were looking at. Let's see how this is going to look. So here we have I equals 0 and while I is less than 3, that's fine. J equals 0. Now we have while true. And notice that we have print, and then we have the same if statement. So if j is greater than or equal to 2, instead of break, we are introducing a return here. And so return should end a function, and we are in a function. Now, if you're not in a function, return will simply just create an error because its syntax is wrong. But we're inside a function, so what will happen? Let's go ahead and trace it through. So as we move through executing the function, I will be equal to 0 and I is less than 3, so j will be set equal to 0. And then we have this while true loop, print I and j, so 0, 0, yes. Is j being 0 greater than 3? No. J will add 1, so now j is 1, and we go up to the top of the inner while true, because that's where we're at. We print ij, so it will be 0, 1, just as we did before. This is false, j is not greater than or equal to 3. We add 1, we get 0, 2. Okay, no, not greater than or equal to 3. Now j plus equals 1 now is brought it to 3. We go back to the top of the while true loop. We print I and j, which is 0 and 3. Is j greater than or equal to 3? Yes, and then we hit the return, which terminates the execution of the function. So what this means is that the while loop, the outer while loop, in fact, only iterates one time. So this loop is not really looping because it doesn't really have the opportunity to, because the inner loop is always going to eventually hit 3 the way this is written. So the loop will terminate. So you probably don't want to do this. But sometimes there are situations where you do want a certain case to be met, and then you hit return and you return that information. So it's just kind of an interesting case to keep in mind. Break will just bring you out to the outer loop, whereas return terminates the execution of your function. And this is just showing the execution of this version. Return in while loop terminates the function. So when you have a return, so what I've done is I've put the return in the outer while loop. So what we have here that differs from the previous example is, you see that I have this case, if I equals 2, it's going to print I equals 2, and then it's going to return. So this will go through I equaling 1, right? And the inner loop will cycle through its 0, 1, 2 as before, because we're back to the regular while j is less than or equal to 3, right? So it'll cycle through 0, 1, 2. Then I will increment up to 1. In the loop, we'll cycle through 0, 1, 2. I plus equals 1 makes I be equal to 2. While I is less than 3, which is a true statement. Is I equal to 2 now? Yes, it is. So it prints I equals 2. That's what we get here. And then return causes the whole function to terminate. So that's what it would look like if you had it in a slightly different place. So then we have talked about while loops in quite a lot of detail now. We have looked at the simple while loops, the while with breaks, the while true with breaks, and the infinite loops. So this is just a nice little summary. We've seen this slide earlier in the week. So hopefully now coming back to this, you can see the patterns here between and get a good sense of the comparison and contrasting features of the various while loops that we've seen. They differ in the branch guard in terms of whether they have the Boolean expression or they just have while true explicitly. And the termination can be achieved in different ways. You can have the branch guard becoming false, and you can have break being encountered. You could also encounter a return if you're in a function, and that would also not only kill your loop, but also your whole function. So then, just bringing this all together, then we've talked about the accumulators and the augmented assignment, which now, as you can appreciate, have quite a lot to do with the loops, which is why we have brought this topic in at this point. Then we looked at the simple while loops. Then we moved on to while with break and the while true with break. Whenever you encounter a break, that terminates the execution of that loop. Then we looked at the infinite loops, and which is usually an accident. And then we had the nesting of loops, which is one loop inside of another. And then we took a look at some of the code for getting out of the loops using break and return with a look at what happens when you have the nesting involved, which makes things more interesting. Break will bring you out of the current loop, but no further. And return will terminate the execution of your function. And of course, return only works if you are in a function, because if you're not in a function, return doesn't apply. All right, well then, I hope that this has given you a good sense of how the while loops work. This is the second element of the flow control. We'll be talking about, well, the major things are the if statements, the while loops, and we'll talk about the for loops with the string processing. They're a little bit difficult to excise from each other because for loops most naturally go with the string processing. So we'll be taking a look at those. And of course, the other element of flow control are the functions, which are maybe not exactly as explicitly flow controls, but that is another one that we have seen that can change the order in which things are getting processed. So then, as you're seeing, we are getting quite a lot of tools now to work with Python, and hopefully you are feeling increasingly confident in your skills and seeing the bigger picture as to how we can fashion code to do the things that we wish to do. All right, well, thank you so much for joining us. I hope you have a great day, and we look forward to chatting with you in our upcoming lectures. Bye-bye.